This is a Seaglider, an undersea research craft that can move through ice-covered waters of the Arctic and operate under the ice itself to help monitor global climate changes. Weighing 110 pounds, the Seaglider was developed by the University of Washington. It recently returned from a record-breaking journey, successfully operating for more than 6 months, making trips under the ice close to the Arctic Circle.
I think our biggest achievement to date has been a very long trip under the ice, something that has never really been done before, to navigate over very long distances and to track freshwater moving under the ice for that long a period of time is really a kind of neat thing.
The Seaglider project is part of the National Science Foundation's Arctic Observing Network, a program to track and understand environmental change in a region uniquely susceptible to climate variations. The poles drive global ocean circulation and act as the world's air conditioners. The samples retrieved in these icy waters contribute to the longest continuous measurement of Arctic currents through Davis Strait that help drive ocean circulation and regulate global seawater temperatures.
The glider reported back profiles of temperature, salinity, and dissolved oxygen from the surface to 1,000 meters, or 3,300 feet. And it made one profile of roughly every 5 kilometers as it moved back and forth across the strait.
Navigating the ice-covered waters of Davis Strait is no easy task. The glider made 2 round trips under the ice, each around 230 miles long. It found openings in the ice to surface 10 times to transmit data about the temperature, salinity, and oxygen content of the water moving out of the Arctic. The Davis Strait is a narrow passage between Baffin Island and the west coast of Greenland. This is where fresh water from the Arctic is dumped into the Labrador Sea and the North Atlantic.
The current program in Davis Strait is actually monitoring one of the major gateways in and out of the Arctic.
The submarine-like vehicle uses GPS to navigate and a satellite phone to call home, to transmit data and receive instructions. When under the ice, the glider navigates using specialized beacons.
The glider goes into the water and then it's on its own. In an open ocean case, it calls home typically every 8 hours or so. And during that time, it reports its data and we can give it new commands.
Gliders operate untethered to the surface or sea floor and are capable of being fully autonomous, making their own operating decisions. This gives them unique range and flexibility. They move without propellers, using an oil-filled bladder to control their buoyancy. The battery pack moves forward and backward to change the glider's pitch. It rotates and causes the Seaglider to roll. The system was designed specifically to navigate in ice-covered regions. The glider's first trip under the ice in December of 2006 lasted only 14 days. Data recovered from the Seaglider will help researchers better understand the role Arctic freshwater plays in regulating the global climate system and how increased freshwater runoff may alter the existing heat balance.